All right, guys, before we jump into our new conversation for today, I just wanted to recap briefly our conversation from yesterday on linear versus proportional relationships. And proportional relationships we have spent a great deal of time talking about. These are the ones that go through the origin and are rising at a constant rate. And we've spent a lot of time looking at tables, looking at graphs, and spending time trying to figure out where or how much these proportional graphs are changing. We call that the constant of proportionality. What's that constant change that keeps happening? So you had 4 tables that you were looking at, and I'm just going to pull these up quick just as a recap. So when we look at table number 1, this is a proportional relationship, and we know that because nothing's added or subtracted, it will go through the point 0, 0. And then we know that the unit rate, or when x equals 1, y is going to equal 4. And that's how this continues to change. We continue to add 4 every single time in the y column as we go up by 1 over here in the x side. And so we spent some time talking about how you can take the y value and divide it by the x value, and that will get you this k, or the constant of proportionality. But now that we have this new type of graph or relationship that we call linear, we need to explore how it is that we can get this value yet again. So we realize when we fill in this table that when x equals 0 right here, y does not equal 0 because of this plus 2. And so we talked yesterday that this point right here is the y-intercept. This is where the graph will intercept the y-axis. And so now we need to come up with a solution for figuring out when we have a linear relationship such as this, how can we determine what that constant of change is, and therefore the number that will go in front of my x. Because we notice that it doesn't just become this number here, this number here with the 1, because it's not 6 anymore. And we can't take the y, like 6, and divide it by 1, because then that gives us 6, which also is not the number up here. So all of that to say, that's where we're headed today, and that's why you have these notes sitting in front of you. Because we're going to introduce how, when we have any sort of equation, this works for linear or proportional tables or graphs, how we can find this number. And we call this number, or the what is being multiplied by x, slope. So what is slope? Slope is just referring to the steepness of a line. Steepness of a line. And we use that when we talk about mountains, when we talk about hills. You guys know what steepness is, and I'm sure in some way, shape, or form have experienced a steep hill or a steep hike, whatever that looks like. And so what we're talking about is just how steep a graph is. Slope is always expressed as a ratio, which we know very well is just a comparison between two different things. And in this case, we are comparing the change that's occurring in y, meaning the y-axis, how it's changing as it moves up and down, and we're comparing it to how it's changing in the x-axis, meaning how is it changing from left to right. And the terms that I'm going to use today to kind of explain that to you, rather than continuing to say change in y over change in x, is rise over run. Because when we look at a graph such as this, the y-axis we are rising either up or down, and then the x-axis we are running either to the left or the right. So that's what I mean by rise, going up and down, over run, left and right. So in our proportional relationships, when we have equations, we used the variable k to represent that constant rate of change. But since these relationships are not necessarily always proportional, we just change the variable to m. So you'll see equations, and yesterday you were just kind of writing a blank and multiplying it by x. That blank we're just going to fill with the letter m, just some number times x. And that number m is the slope. That's what's representing the steepness of that line. So when we read a graph, and the graphs that you created and the ones that we're going to read today, we always go to the right. And this is just like how you read a book. When you're reading a book, you go from the left side of the page starting here, and you go across to the right. And that's just the same exact way that we're going to read the graphs that we look at today. The one thing to keep in mind as we do this, and we'll practice a whole bunch before you try this on your own, is that lines can have different types of slants. In the real world, we refer to this as uphill and downhill. But in a graph, obviously these aren't actual hills or mountains, so we just talk about their slope. And so lines that have a positive slope, where the number is positive, those lines are going to slant upwards from left to right, meaning they're going to go in this direction. So going from left to right, they're going up the page. Lines with a negative slope are going to slant down. These are our downhill, and so they'll go down the page like that. That would be a negative slope. An uphill, or something that looks like it's going up, is going to be a positive slope. So the goal is to be able to calculate slope, and we've talked a little bit about this trifecta, and it really is a trifecta because this slope you should be able to calculate from any members of this trifecta. Today we're going to look at specifically graphs, and we're going to learn how to calculate slope from graphs, but you should also be able to do it from tables and from equations. Any of those three members of the trifecta, you will eventually be able to figure out the slope or the steepness of the line. So we're going to try this a couple times together. You're going to have a little check-in to complete, and then maybe a couple extra practice problems as well, just to get practicing how we calculate slope. But we're just going to follow these simple instructions that are actually written right here for us. We're going to begin with the left point, so the first point that we come across as we're reading from left to right, and then we're going to count the rise, which is again how it's changing, going up and down, and then the run to move to the next point. So we're going to draw what I like to call slope triangles, just to show us better what these things are. So I want you to pick up your pencil and put it right on that first point that you see in this first graph. Again, that's the leftmost point that we're starting with. And we're going to count the rise. What I mean by that is going up or down, how many spaces do we have to move to get to this other point? In this case, we have to go down, and so I'm going to put a negative 1 space. 1 box is our rise. We have to go down, and then our run, we are going over to the right 3 spaces. So since we calculate slope as a ratio between the change in y, or the rise over the change in x, all we have to do is take those numbers, the difference as it's changing, and put them into a ratio form, which is what this line over here is for. So we're just going to put the change in y, or the rise, which was negative 1 over 3. So the slope of this line is negative 1 over 3, or negative 1/3. And you can see that no matter where really we put this triangle, if we connect one point to the next, all of these little slope triangles are the same. We're always going down 1 and over 3. And that's simply it. That's how you find the slope of a line. So we're going to try it again here with the second graph. Again, we're going to start with the first point, the one on the left. We're going to figure out the rise. Again, that's going up or down first. How many spaces do we have to move in order to get to the next point? In this case, we have to go up 3 spaces. So it's a plus 3. And then our run is to the right 2. So to find the slope, or to write the slope, we write it as the rise 3 over the run 2. So 3 over 2 would be the slope. For the third graph, we'll do it again, starting with the left point. How much are we moving up or down? In this case, we're going up 1. So I've got plus 1, and then we're running 2. So moving over 2. So when we write this in our ratio form, we do 1 over 2, or 1 over 2 as our slope. And again, I'm just going to echo that wherever these 2 points would be, it's going to be the same. So I drew 2 more points that fall on this line, and it also is up 1 over 2. Over here, if we draw another one, it's also up 1 over 2. That stays constant the entire way through. That's why we call it a line. So last 3 we're going to try together, starting with the left point. How many spaces are we moving up or down? I'm counting up. My rise is a 5 spaces, and my run over is 3 spaces. Therefore, the slope would be 5 over 3. Change in y, or the rise over the run, 5/3. And notice these are positive slopes because all of them are going uphill, except for that very first one we did. That was going downhill, which is why we had a negative slope. So example number 5, we're starting at this point here, the one on the left. Are we going up or down to start? In this case, we need to go down 3, which is where our negative slope comes in. Again, this is a downhill line, so we're going down 3 or negative 3 and running 2. So negative 3 over 2 would be my slope. And the last one, see if you can give it a try. Pause it quick and then check in with me to see if we got the same thing. You should have found the rise. We went down 2, and then the run was over 2, so our slope would be negative 2 over 2. And the neat thing really is that we can simplify all of these. All of them so far has been in the simplest term, but we can simplify this ratio negative 2 over 2 to negative 1. And so the slope would then be negative 1. So hopefully you've picked up on the pattern. We're just finding the distance, the change between these 2 points on a graph, putting it into a ratio of the rise, or how much we're changing in the x and the y, over the run, how much we're changing on the x-axis. So if you turn the page over, you actually will see this page, which I want you to skip for now. We will come back to it. But if you look at the 3rd page in this packet that I've given you, you see 4 more graphs. This we're going to count as your check-in. So this is what should be completed before you leave my room today, and you should check in with me. You're finding the slope of each of these 4 lines, and you can just write it over in the space next to each of the questions. And then again, come check in with me. We'll see how you're doing so far.